solve this particular differential equation. So this will how your exams are going to look like, right? There will be no instructions or guidance towards which particular method you need to use, okay? So I'm going to pretend that I'm not doing the exact solution at this point. Obviously, I'm going to practice that. That's the whole point of this particular segment. But I will go ahead with the order of what I covered. So the first thing is this an autonomous equation, right? Because I showed you how to solve those. So the x, well, it's here. So that's the answer is no, it is not, okay? Let's go to the second one. Is this a separable equation? Let me take a look. That may need a minute from my side. So let me move the x over there. No, I have a negative y. If this was like a multiplication of y, I was able to do it. No, this is not a separable equation. Third is to check whether this is linear. Let's take a look. X times dy dx is equal to, if I move minus y to this side, actually this is a linear equation. You see that, right? Because if I move minus y to here as a plus y, so that will be, x is a function of x, plus 1y, which is okay, and the right hand side is only a function of x, g of x, right? So for that reason, this is linear. But let's practice doing the exact equation approach, okay? Obviously, I cannot simply go ahead and use the exact equation approach. The first thing I have to make sure that there is an exact differential that will be able to capture the behavior of this differential equation, okay? But let's move things around so this looks like more like in the differential form. So I'm going to move the x over here, and then x times dy, I'm going to move that to here and say is equal to 0. Okay, so that will be the first step. 2x, let me see, e to the x minus y plus 6x squared dx minus x dy is equal to 0. Okay, from the previous segment, this is n and this is m. And I want to write it in here, del f, del x, del f, del y. So the very first thing that I have to do is to check whether this is a exact differential. In order to do that, you remember from the previous segment I have this. Is it really equal to del n, del x? Okay, so let's insert m, del y of 2x e to the x minus y plus 6x squared. Is it going to be equal to del of, well, minus x, right? Kind of quick, del x. Okay, let's do the left hand side. This doesn't have any y, so there's minus 1, right? Minus 1. And the last term doesn't have any y in it as well, so the left hand side turns out to be minus 1. Let's look at the right hand side, and you can clearly see this is minus 1 too. So this is an exact differential, all right? So I will be able to use the approach that we have established in the previous segment, okay? My warning to you is that do not forget to go through this process. Okay, sometimes I see this, students just simply go ahead and try to find it. Okay, now that we have established that this exists, so the big question is how am I going to find the exact differential, right? Well, actually the hint is over here, so let me actually change colors. I'm looking here, right? So this m is a function of xy will be equal to del f of xy del x. So can I just move simply this guy to over here and take the integral of both sides? Of course. Let me do it. Yeah, why not? Right? So let's do it. So what will be the integral of this side and this side, right? I'm going to write it to the left hand side, but it will be fx comma y, right? The right hand side will be the integral of mxy dx. So let's do it. So this will be equal to integral of m was 2x e to the x minus y plus 6x squared dx. Okay, I'm proceeding nicely. Except that, when I look at the first term, I see x times e to the x. Now, recommendation, memorize this. This happens too often in mathematics, at least in my course. Let me write it over here. X times e to the x dx will be equal to x e to the x itself minus e to the x, right? So, or you can call this e to the x, parentheses x minus 1. So memorize this, but let me show you how to do this. It's not a biggie. We talked about this, integration by parts, right? So I'm going to call this u will be equal to x. So du will be, well, 1, right? What about dv? Again, let's write it in here so I can be consistent, so everybody's on the same page. Integral of u dv will be equal to uv minus integral of v du, right? That's what I'm trying to establish. What is u, what's dv? and use this dv is the remaining, so that will be e to the x, so then v will be equal to e to the x, right? Okay. So then I will proceed with solving this particular equation. So this will be 2 times of uv, which is x e to the x, see, that's the first term I talked about, minus integral of e to the x dx, right, minus y x plus 2x cube, okay, plus, now here's where you will be confused, okay. You know, since maybe high school, we've been taught that this will be a plus c, right? So now if you write here plus c, that will be a mistake, right? Let me explain what I'm talking about if you're, like completely surprised what's going on over here. One thing is, let me actually go ahead and delete this so it looks kind of neat. There we go. I want to look at this particular equation. I'm taking the integral of this. Did you realize that this is partial, right? So in partial differentiation, what I do is I keep y constant and take the partial with respect to x, or the derivative with respect to x, right? That's the whole point of taking a partial derivative. Now, if this was a regular derivative, like a d sign over here, I'm going to write plus c and call it a day, all right? But in this case, it's a partial. When I have a partial, I must represent the other function that I hold constant, okay? In this particular case, it's a g of y, all right? And if you didn't see this, I want you to actually take this and plug that back into here and see what happens. Let's just look at the last term. When I plugged it in, I will have this plus g of y. What is the derivative or the partial of g of y with respect to x? It's 0. You see, you will go back. So this information is lost if you just put a plus c there. So this is something that you must know. It's kind of important. Okay? But if I proceed with it, you will see that this f x comma y will be 2x e to the x minus 2 e to the x minus xy. Let's just write nicer. 2x cubed plus g of y. So now the question is, am I done? Because the question was to find f of xy, and I did find it. Well, yes and no. I did some good things. I was able to obtain some terms of this, but I still have an unknown over here. That's a g of y, all right? So I have to do something about it to find my g of y. So here's how I am going to find my g of y. Take a look at this boxed up equation. Did I even touch that? This whole question, let's say that this was not minus x, but something else. This equation still have been exactly the same. So I didn't really touch this equation. So now I'm going to take advantage of that and find my g of y, all right? The other point I want to make here is, you see, I started with this. I don't have to. If I choose to, I can start with this equation. But then what I will have a, in this particular case, a minus x integral with respect to y, and then you're going to write plus g of x will be of f x comma y, right? And then in the second step, you will touch the equation that you didn't touch yet. So, and the final answer will be the same, okay? So sometimes, a hint to you is the equation that you start with over here. In this particular case, I start with this, right? So when you take the integral of this, make sure that you can take the integral of what is here, right? So I want to make sure that I want to start with a function that I can take the integral of. And if in this case, I can take the integral of both, so it doesn't really matter, right? So if you find that, hey, this is really hard to find the integral of, then you may want to start with this boxed up equation, so you can proceed and find your f and then take the derivative, etc. Okay? Just want to let you know. Okay, so then let's write the second equation, which was n is equal to del f x comma y del y, right? So let's do that. N is minus x will be equal to del y of that 2x e to the x minus 2 e to the x minus xy plus 2x cubed plus g of y, right? One more parentheses. Okay, I'll do the left hand side. I'll ask you viewers to do the right hand side. How about that? Is that fair? I don't know. I just did the left hand side. Anyways, let's be serious. So there's no y here. There's no y here. So far so good. So these two terms dropped out. The third term becomes a minus x. You realize that, right? The fourth term doesn't have any y in it, so I'm good. The last term, I'm going to call this plus g prime of y, where g prime of y is equal to d g of y dy. Immediate question. Why did I put a d, not a partial? Right? Because this whole thing says partial, and I said d. Well, because you need to look at the definition of partial and derivatives. You see, there's only one independent variable. As long as there's one independent variable, that's the special case of a partial, and it's called the regular derivative. All right? So you can see that's the reason why I get myself a d. This is important because when you take this g, like let's say this particular example, you can see these two cancel, and I get myself g prime of y is equal to 0, right? So then for a student who writes here partial, then you're going to write here, when you take the integral of this, you're going to say plus f of x, right? So you not good because you introduce another function that you shouldn't have both, okay? So in this particular case, then I'll have an integration constant of plus c, right? So from here, I will get myself g of y to be constant of c. The funny thing about this whole thing is I said that g of y is not c, but then I did a lot of process and I showed you that it's supposed to be a c, okay? You know what this is called? It's called a coincidence, right? This may not repeat, and most likely it may not repeat in the real exam purposes, okay? I want you to understand that. But when all said and done, then I will rewrite this whole thing. So basically, I just insert this gy to be plus c here. And I got myself fx comma y will be equal to 2x e to the x minus 2 e to the x minus xy plus 2x cubed plus a constant of c. I'm kind of done, but not quite. Just one more last step. Here's the last step. When I was explaining in the previous segment, I take this as a constant. Remember that? Even in the examples that I give, it was that's how it's defined. Why? Because the way that I explained the differential form is the right-hand side was 0. When I take the integral, I get myself a constant. Obviously not c, but some other constant, right? So now what I'm going to do is I'm going to have this constant, and I'm going to have that constant, and combine them into another constant. And now that will be my final answer. 2x e to the x, 2 e to the x, minus xy, plus 2x cubed is equal to k. So obviously k is a c minus whatever the constant, integration constant of fx comma y is, alright? So it's an arbitrary constant. Thank you for watching this video. The next thing I'm going to do is I'm going to solve another question to illustrate these fundamentals.